Hello everyone, welcome to my channel on engineering mathematics. In this video on inverse Laplace transform, I am going to discuss examples based on differentiation technique. Guys, in my previous video, I have already discussed this method in detail and solved few examples on it. In this video, we are going to see some more examples based on the same concept. So let us first recall this technique. Using this technique, you are going to see how we can use the derivative of the function to find its own Laplace inverse. For that, let us recall the effect of multiplication by t rule to find Laplace transform of the given function f of t, which states if Laplace of f of t is phi of s, then Laplace of t into f of t is minus phi dash of s, where this phi dash is derivative of phi of s. Now let us take this L on the other side. We will also take this T on the other side. Therefore, we get f of t is equal to L inverse of phi dash of s into minus 1 upon t. But note that this f of t is nothing but L inverse of phi of s. So when this f of t is replaced by L inverse of phi of s, we see L inverse of phi of s is equal to minus 1 by t into L inverse of phi dash of s. Which means if you wanted to find out L inverse of a given function phi of s, you simply find out L inverse of its derivative and multiply it by minus 1 by t. So using this as a formula, we are going to solve some examples. Let's go for our first example. Here we are asked to find L inverse of log of s plus a upon s plus b. Now let's look at the solution. Using the rule of derivatives to find out L inverse, we can write L inverse of log of s plus a upon s plus b is equal to minus 1 by t into L inverse of derivative of log of s plus a upon s plus b. Now let us find out derivative of this function. But before finding derivative, let me use log a by b rule, which says log a by b is log a minus log b. So we have now log of s plus a minus log of s plus b. Now let's find out this derivative. Derivative of log of s plus a is 1 upon s plus a, and derivative of log of s plus b is 1 upon s plus b. Next, we operate this L inverse on each of these two terms. Therefore, we get minus 1 by t into L inverse of 1 upon s plus a minus L inverse of 1 upon s plus b. Finally, we find these two inverse Laplace transforms. Inverse Laplace transform of 1 upon s plus a is e raised to minus at, and inverse Laplace transform of 1 upon s plus b is e raised to minus bt. Therefore, minus 1 by t into e raised to minus at minus e raised to minus bt is inverse Laplace of log of s plus a upon s plus b. I hope guys you understood all the steps involved in this solution. Now let us go ahead for next example. Here we are asked to find L inverse of tan inverse of 2 by s square. Let us proceed for solution. We are going to use the same derivative formula to find out inverse Laplace of this function, according to which L inverse of this function is minus 1 by t into L inverse of derivative of this function. And what is derivative of tan inverse? It is 1 upon 1 plus 2 by s square the whole square into, by chain rule, derivative of 2 by s square is minus 2 by s square whole raised to 2, that is s raised to 4, into derivative of s square, which is 2s, which when simplified we get minus 4 upon s cube into 1 upon 1 plus 2 by s square whole square. Let us further simplify this by cross multiplying these two terms and then cancelling with this s cube. We get minus 4s upon s raised to 4 plus 2 square. Guys, you can pause the video and check this calculation. Now, here I see we have to find inverse Laplace of minus 4s upon s raised to 4 plus 2 square. There is no direct formula to find out this inverse Laplace. In denominator, I can see these two terms are of the type a square plus b square. So here a can be considered as s square and b can be considered as 2. Now we will adjust plus 2ab term into this to get a plus b the whole square term in the denominator. So what is 2ab in this particular case? A is s square, b is 2. So 2ab is 4s square. So we will add 4s square and subtract 4s square from the denominator in this way. Now these first three terms forms s square plus 2 the whole square. Let's write this as s square plus 2 the whole square. And this minus 4s square can be written as 2s the whole square. Now this is like a square minus b square. A square minus b square is a plus b into a minus b. So this is a plus b into a minus b. Now we are going to use partial fraction to separate these two terms. So after using partial fraction, we get 1 by 4 upon this first factor minus 1 by 4 upon this second factor. Guys, I haven't shown the complete steps of the partial fraction over here, but you can do them in rough and check this calculation. Next, I'm going to write this denominator as s minus 1 the whole square plus 1 by splitting this 2 as 1 plus 1. Similarly over here, by splitting this 2 as 1 plus 1, we get s plus 1 the whole square plus 1 in the denominator. This 1 by 4 is constant and common. You can take it out. Now operate L inverse on each of these two terms in this way. Now I see here s is associated with minus 1. So this function can be treated as phi of s minus 1. Similarly, this function can be treated as phi of s plus 1. Then by using first shifting theorem, L inverse of phi of s minus 1 is e raised to t into L inverse of phi of s. So we get e raised to t into L inverse of 1 upon s square plus 1. Same thing over here, by first shifting theorem, L inverse of phi of s plus 1 is e raised to minus t into L inverse of phi of s, which is now 1 upon s square plus 1. Now there is direct formula for L inverse of 1 upon s square plus 1, which is sin t. So we replace these two terms by sin t in this way. Now sin t is common. You can take it out and further simplify it or reduce it. But we can declare that this is inverse Laplace of tan inverse of 2 upon s square. I hope guys you understood this solution. Now it is your turn to solve some examples. These are a couple of examples for you. Their final solutions are also mentioned over here. Guys, please write me in comment box whether you are able to solve these examples and whether you got these solutions or not. If you like this video, please click on the like button and share this video among your friends. Guys, keep watching my video and write me in comment box. This encourages me to develop such content for you. Thank you all of you. Thank you for watching this video. Please subscribe my YouTube channel and press the bell icon to get updates about my new videos.